Right, let's carry on with trig, okay? Because we're now learning how to put angles and shapes into our understanding of maths. And really, at the end of this, you'll be surprised what you can do with a tape measure and a protractor and a ruler, just for fun, measuring how far you are from things and just generally getting an understanding of how many things actually work in life. All right? Now, let's just have a look over here. All right? Right, let's say. Okay? Let us look at special angles. Right? What is a special angle? Okay? Well, special angles are basically really, for those of you, and I know I can't say for those who don't do EGD, but just for those who do, you've got these. You work with them all the time, right? Really, it's worthwhile looking carefully at this and understanding that's a 45 degree, that's a 45, which means that this and this length is the same because the base angles of an isosceles triangle are the same. That's an equal length, right? 45, 45. Here, we've got a 30 degree and 60 degrees, right? So if you've got a protractor, okay, please have a look, take a protractor, put it down on your thing, on a line, draw a baseline over there, put a line, draw an angle of 30 degrees, measure it, okay? Put a dot and join it. Draw 45, do it. Draw 60, draw 90, right? Look at where this side here is greater than 90 degrees. This is 180 degrees, right? Now, how do we draw an angle of minus 30 degrees? Negative 30 degrees, negative 60 degrees. Where are they? Well, do you remember? How do we measure? Okay, we measure that way positive, which means what? We measure that way negative, right? So if you want to draw minus 30 degrees, you would turn your protractor upside down, unless you have the protractor, which is the full 360 circle, right? You turn it upside down and you would measure 30 degrees that way and draw the line, and that gives me minus 30 degrees. So therefore, if I've got minus 30 degrees, the plus angle must be plus 330 degrees. Why? Because the 330 and this 30 here must be equal to 360. It really and truly is worthwhile getting to know these angles, what they look like, right? Now, let's just go on and have a look at these two triangles over here. Let's just take this one first. Okay, let's move that out the way. Right. I'm going to draw this triangle. There it is. There's my 90 degrees. Now this side and this side are equal, right? So I'm going to call them 1. One of my students the other day that I'm tutoring said, why? Because 1's an easy number to work with. You can call it whatever you like, but 1's just a simple number, right? Therefore, this is this triangle. What is the length of the opposite side, right? First of all, let me fill in here as 45 and 45, like that, okay? Right. What's the length of the opposite side? It is the square root of 1 plus 1. It is root 2. You have to remember this. The short sides are always 1. Let us do the same for the other triangle that's over here, right? There. So let me draw it. Right? 30 degrees, 60 degrees, and 90 degrees. Please note that the 30 and the 60 add up to 90, right? That's an important thing to remember later on. Grade 11, we're going to be using that quite a lot. Okay, so how do I find numbers for this one? Simple. You call the short side 1. Okay? And, well, we call this one 2. Therefore, that becomes root 3. I always remember, I just know how to draw them. Please, please, please learn these. Make up your own mnemonics, whatever you want. All I can say is the 45 one, these two sides are 1, they equal, which automatically gives that as root 2. This guy here, I remember it as the short side is 1, same as the other one. And I then make the hypotenuse 2, because I know that it's 1, 2, root 3. If you are stuck as to which is which, okay, just remember the hypotenuse is the long side. Root 2, okay, 2 is greater than root 3. So if you remember 1, 2, root 3 and get stuck, 2 is bigger than root 3. Okay, so do draw some angles on a piece of paper. You know, practice them. You won't regret it, that I can tell you. Just a few, you know, you don't have to draw a lot. Get used to angles and adding them together to get your 180 degrees. Now, we've got it. Now, let's just have a look with those triangles, right? You look at yours and let us fill in this table over here, shall we? Fill in this table with me. Sine of 30 degrees. Cos of 30 degrees. Tan of 30 degrees. Okay? And we're going to do 60 degrees as well. Sine 60 degrees, cos 60 degrees, and tan 60 degrees. And guess what? Yep, we're going to do 45. 5, cos 45, and tan of 45. I very often forget the degrees out. My apologies for doing so when I do. So now if you look on your triangles, right? You go to the 30-degree side. Let me move it back up, right? So now we are busy working. I'm going to change color. We are busy working with this angle. So what did I say? Stand in the angle and find opposite, adjacent, hypotenuse. Okay? Believe me, this is going to go right through till grade 12. Find opposite, adjacent, and hypotenuse. What do we do then? Well, the next step is we say, okay, let us now go and look at what trig functions we are being asked for. We're being asked for sine, cos, and tan. You remember, sine is opposite over hypotenuse. Cos is adjacent over hypotenuse. And tan is, okay, opposite over adjacent. All right. Well, how do you remember this sort of thing? I'll show you a little mnemonic in a bit, which I picked up from somewhere as well. Okay, sine of 60. And now let's go back to our triangles, right? Now we're working with the 60 degree. Oh, yep, let's finish this. We're now working with the 60 degree. So I say opposite, adjacent, hypotenuse. Hypotenuse always stays, doesn't it? But the opposite and the adjacent have flipped. So, right, let's now go back and let's fill in the table, right? Fill in the table on your side and then compare it with what this looks like. Okay? Okay, I'm going to put those down there like that. Okay? So, sine of 30 opposite over hypotenuse. So we would say that is 1 over 2. Root 3 over 2. 1 over root 3. Sine of 60, root 3 over 2. A half. So tan, root 3 over 2. Root 3 over 1. Okay? Then we can do the same for the 45, right? Sine of 45, so let's go back to it. Shall we? Now it doesn't matter. Opposite or there. So adjacent and hypotenuse. Go back and just fill them in. Okay, what do we get? We get sine of 45 is going to be equal to 1 over root 2. 1 over root 2. And over here is going to be root 2 over, 1 over 1. It's going to be 1 over 1, which is 1. Right? Please note something very interesting. sine of, let me write this down a little bit. Can you see here? Sine of 30 degrees equals cos of 60 degrees, and sine of 60 degrees equals cos of 30 degrees. Right? That is in effect because these two are complementary. They add up to 90 degrees. So whether you've sine 30 and cos 60 is actually the same thing, the same number, okay, on the triangle. And we'll get to that as well later. So sine of 20 is cos of 70, okay? Let's have a look at this. Right? Please remember this, okay? Sine of 50 degrees, let's look. Sine of 50 degrees, and I look it up. How? Calculator, 0.766. Therefore, what's the complementary angle? Is cos of 40 degrees, because plus 40 must equal 90 degrees. Cos of 40 is 0.766. Therefore, sine of alpha must be equal to cos of 90 minus alpha. Okay? This is worth remembering. The sine of the angle is equal to the cos of the complementary angle. Okay? We're going to use that quite extensively a bit later. Okay? Now, let's use these special angles. They say to us, these are the kind of questions that we're going to get. They say to us over here, evaluate or simplify without the use of a calculator. Evaluate or simplify. You've seen them since last year. It's always the same pattern. Everything we do, we're going to simplify and we're going to cancel stuff out, because simplify means make it smaller. So let us say, or evaluate means work it out. They've said to us sine squared of 60 degrees plus cos squared of 60 degrees, right? How do we do it? All right, step one, okay, we say, right, step one, identify the special angles. Okay, here we've got 60 degree. Step two, draw the special triangle. So I go and I say here I've got 60 degrees and that's my 30 degrees by 90, 1, 2, root 3, right? Then next, okay, recognize the initials. So step 3 is change that to sine of 60 degrees squared plus cos of 60 degrees squared, okay? So move that out so that we're just working with that, okay? Now, question 4 is, or not question, substitute in. What is sine of 60? What did I say? Go to the angle, okay? Identify opposite, adjacent, and hypotenuse, right? Go to the angle, identify opposite, adjacent, hypotenuse, okay? Then we say, right, sine of 60 degrees is opposite over hypotenuse, is root 3 over 2, and we've got a square over there. Then we look at cos, which is a half, and we've got a square over there, right? Now, what is root 3 over 2 squared? What do we do? It is root, come on. It's root 3 squared, right? What is root 3 squared? It is, right? It's going to be equal to 3. 2 squared is 4, plus 1 over 4, which is equal to 4 over 4, which is equal to 1. Okay? It is equal to 1. Okay? This is something called an identity. Okay? And it says that sine squared of theta plus cos squared of theta is always equal to 1. It doesn't matter, it's sine squared x plus cos squared x equals 1. It means that if you take the sine squared of the one angle and the cos squared of the same angle, it always gives you 1 when you add them together. Okay, please look in your books, there is a proof of that, all right, where you basically just use a triangle AB and the other side is root, okay, and you just substitute in exactly as I just did, all right. Now they say evaluate sine 45 over cos of 45 degrees, right? Well, let's have a look. Now we've got to go and draw our step 1, identify which special angles, and step 2, draw it. There we go. 1 root 2, okay? Then we substitute. So what is sine of 45? We substitute in brackets, right? Sine of 45, 1 over root 2, isn't it? 1 over root 2. Cos of 45, remember, in this case, it didn't really opposite adjacent hypotenuse, is 1 over root 2. 1 over root 2. Now, here's something to remember. How do I do? You can see it's 1, they cancel out. But how do we do it? We say 1 over root 2 divided by 1 over root 2. Fraction, which means I tip it and times it, which gives me 1. Okay? This you're going to do a lot. Okay? This tipping and timesing thing you are going to do a lot in these trigonometry questions, right? Now, let's say, well, first of all, that means another identity here. And that is that tan of theta is equal to sine of theta over cos of theta. Because why? This is equal to tan of 45 degrees is 1. Have a look at it. Opposite over adjacent, 1 over 1. Here it is. That divided by that. That length and that's the same. So it's 1. So sine theta over cos theta is equal to tan theta. That is another identity that you've got to remember. Okay? Now they say evaluate this. Evaluate this. All right? Half sine squared of 60 degrees. A half of sine squared of 60 degrees minus 3 times tan squared of 30 degrees. Okay. First of all, we've got a 60-30 triangle. So let's prep our work on the side. There's our 30. There's our 60 degrees. 1, 2, root 3. Right? What do I do next? I'm going to remove that square just for safety. And I'm going to say that's the sine of 60 degrees all squared minus 3 times the tan of 30 degrees all squared. Right? Then I say, right, now substitute in. That's a half times, what is sine of 60 degrees? Okay? Sine of 60 degrees is going to be, whoa, hang on. Let's go and look for our opposites and adjacents again. Opposite, adjacent, hypotenuse. So sine of 60 is root 3 over 2. Okay? So I substitute in root 3 over 2 squared. Minus 3 times tan of 30. Whoops, now I've got to go to 30. So now my opposite has changed. Okay? The tangent of 30 is 1 over root 3, isn't it? Okay? 1 over root 3. Okay? So therefore, basically what have we got? Root 3 squared is 3. 2 squared is 4 times 2 is 8. Agreed? Minus, what is this? 3 times 1 over 3 is 1. My answer is minus 5/8. Okay? Right? Oddly enough, this step here is the one that seems to trip up most students. It's actually the working with the fractions, right? Now, the sad part is that a lot of the trigonometry is requiring you to do this, okay? and you can't get away from it, all right? Now, the next section is, what if the angle they've given us isn't a special angle, right? What do we do then? Well, we're going to do a recipe for it. Simple. Let's say we are told that sine of theta is equal to 5 over 12. And they say find, without a calculator, they want to know cosec times sec, all right? Okay, first of all, we're going to define, what am I talking about, cosec and sec, all right? I haven't spoken about that. Those are basically the opposites of the sines and the cos. Let's just say here, if you've got sine theta, that is 1 over cosec theta. Cos theta is 1 over sec theta. And tan theta is 1 over cotan theta. All right? Let's just look at those a different way. All right? Basically, we are saying that sec theta is 1 over cos theta. Cosec theta is 1 over sine theta. And lastly, cotan, that's cotangent of theta, is 1 over tan theta. All right? Those you've just got to commit to memory. How? Well, here's a little thing. Sec is cos. They're opposite. You'd expect sec to be sine, but it's the opposite. Cosec is sine. Instead of cosine, it's sine. So they are opposite over there, right? And cotan and tan is easy to work out. If you look at your calculator, you won't see sec, cosec, or cotan. It's not used that much, right? Because they are just the inverse, the opposites of the other functions. So we always go to put it into the other functions first. Okay. Now let's get back to our problem, shall we? What did our problem say? Our problem said they've told us sine of theta is 5 over 13. Okay. What do we do first? We make a sketch. And we make a drawing like so of our triangle. And we call that theta because we don't know it. But they have told us that the sine of theta is equal to 5 over 13. Sine is opposite over hypotenuse, isn't it? So what do? We go to our things and we say opposite, adjacent, hypotenuse. Hang on. The opposite is 5. The hypotenuse is 13. They've told us. So therefore, I can go and work out what that one is. How do I do it? Pythagoras. So we say 13 squared is equal to 5 squared plus a squared. Therefore, a squared is going to be equal to 144 because that goes over as minus 25. 169 minus 25. Therefore, a plus or minus 12. Okay, so it's going to be equal to 12 because I'm in the plus side. Don't worry, we'll get to that in a little bit. Okay, so there we go. Now they've said, right, what is cosec times sec? Cosec of theta times sec of theta. Well, I first changed that to 1 over co. Hang on. Co means it must be sine theta times 1 over cos theta, which is what? We go back to our sketch, and you can fill it in, all right? And you say that it is 1 over 5 over 13 multiplied by 1 over 12 over 13, like so, right? And that is the same as this, isn't it? 1 divided by 5 over 13 times 1 divided by 12 over 13. Please practice these. Okay, I cannot overemphasize how important this is in this part of the work. Well, what is that? We go 1 times 13 over 5 multiplied by 1 times 13 over 12, which is going to be 169 over 60. Okay. All right. Okay. Like that. And then basically we're going to change it up and we could subtract stuff. I had in here minus cot theta. Let's put that in, shall we, as a red. Minus cot theta. So I'd have said, right, that's there, minus 1 over tan theta. Can you see we just do the same? And tan theta is 5 over 12, okay, minus 1 divided by 5 over 12, which is minus 12 over 5, all right? And basically, the end result's going to come out as 5 over 12. Okay? Why? Because that 12 over 5, we've got minus 12 over 5. Okay? 169, I changed that to a 60. It's 169 minus 44. 169 minus 40. Let me just do it for you. Okay? That is going to be 169 minus 144 over 60, correct? Which is going to be 25 over 60, which is 5 over 12. All right. Probably one of the most difficult of the lot to do in essence, okay? But the trick here isn't actually working out what the sine, cos, and the tan is. It's actually doing the fractions part. So here you really need to go back to basics and make sure you fully understand how to divide by fractions, multiply by fractions, and square fractions, okay? Please make sure that you've got that under the belt, okay? The next session we're going to look at is solving actually triangles. Very interesting section that brings to light a lot of the things, the way we actually do things in life. Cheers. I'll see you in the next session. Bye.